In this video, we are going to be looking at some of the physics behind bat and ball speed in baseball. Our own naked eyes can see that a ball coming towards the batter is going away from the batter faster after the hit is made. But why is that? Well, a lot of it has to do with the bats. Bats are measured by a system called bat-ball coefficient of restitution, or BB-core. At its base, a bat's BB-core percentage is the ratio at which the bat utilizes the input energy and momentum by the batter. In this experiment, the bat used has a BB-core of 0.528 after specific variables were plugged into the BB-core equation shown here. After a revamp of the guidelines made by BB-core, this bat has been made legal by Babe Ruth and college baseball standards. Alongside this is the more basic physics fundamental of conservation of momentum. Based on this, the momentum of the bat's input and the ball's input should equal the combined output of each. This proves our earlier theory that we observed with the naked eye. Although the vibration and collision of ball and bat causes a loss of 82 to 90% of the system's energy that we observed in our experiment, momentum of the ball collides and bounces off the bat, utilizing the bat's momentum as a catapult and propelling the ball much further in the opposite direction. A bat's sweet spot is the location on a bat where the least vibration due to contact occurs, meaning that less energy is lost, which sends the ball flying further.
One of our hypotheses why we lose energy is because we believed that energy is absorbed in the vibrations to the hand. However, in this video, we see you don't even have to be holding the bat at the same time of the collision, because the ball-bat collision takes less time than the vibration of the ball hitting the bat takes to travel to the hand. So since the ball-bat collision happens in less than a millisecond, and it takes longer for the frequency waves to travel down the bat, as long as the bat is still moving at the same speed towards its target, anything can happen with your hands. This allows a home run to still happen, even though Todd Frazier didn't follow through with the swing. Because of the conservation of momentum, the bat is still moving forward at the same speed if you release the bat at just the right time. Most of the loss of energy comes from the collision with the bat, because both the bat and the ball have elasticity. Elasticity is how much energy is stored in the bat or ball that is returned as kinetic energy. Where the stiffer the object, the less energy is dissipated in a collision. Baseballs are made to compress to nearly half of their diameter, losing 75% of their initial energy. In the aluminum bat, the bat is designed to have the ball compress the barrel of the bat. The more the barrel compresses, the less the ball has to compress itself, saving more of the energy in the ball, meaning the higher BB-core a bat has, the more its barrel compresses to save the energy of the ball, and the higher core a ball has, the less willing it is to compress. The compressed barrel also acts like a spring on the ball. This is why BB-core is important to test for in aluminum bats, because if it didn't try to level the playing field between wood and metal bats, the metal bats would easily outperform the wood bats. This is why a BB-core has to be less than 0.5 to act like a wood bat, and how much energy it removes from the system. It is also important for the safety of the players on the field, because if no energy was lost, the balls would be traveling much faster, and in the professional league, those balls already travel over 100 miles per hour. You don't really want anything faster than that traveling at your head.